Hello students, myself Archana Varude from Praveen Patel College of Diploma Engineering and Technology. Today we are going to start chapter number 3, that is photoelectricity, X-rays and lasers. And after watching this video, students will be able to understand what is meant by photoelectric effect, what is meant by Planck's hypothesis, and how the energy of photon is given. First we see what is by photoelectric effect, and it is found that certain metals like magnesium, zinc, lithium, when exposed to ultraviolet light, then they emit the electrons. The meaning is that when ultraviolet light is incident on these metals like magnesium, zinc, lithium, then they emit electrons. Then it is also observed that some alkali metals like sodium, potassium, they are sensitive to even visible light. That means when ordinary light, that is visible light, falls on these alkali metals, that is sodium, potassium, then electrons are emitted. That means here it is observed that when light of suitable frequency is incident on metal surface, then electrons are emitted, and therefore that effect is known as a photoelectric effect. And we say that when light of suitable frequency is incident on metallic surface, then electrons are emitted from that metal surface, and this effect takes place under the influence of light, and therefore it is called as a photoelectric effect. And in this case, that electrons are emitted, and the emitted electrons are called as photoelectrons. And in short, here we write photoelectric effect means when light energy is converted into electrical energy. But the condition is that when light of suitable frequency is incident, then electrons are emitted. Then what is my Planck's hypothesis? This Planck's hypothesis is also known as Planck's quantum theory. And here the scientist Planck proposed the quantum theory for explanation of energy distribution in black body radiation. And according to this theory, energy is not emitted and absorbed continuously, but it is in a discrete packets or units, and these energy packets or these energy bundles are called as photons or quanta. And here it is observed that the photons are electrically neutral and they travel with speed of light, and that is the radiation is considered as a shower of photons. Here, if V is the frequency of light, then energy E associated with that photon is directly proportional to V. Therefore, here we write E is directly proportional to V, where E means energy, V means frequency of light. Then, when we take equal sign in next step, consider constant on right hand side. Therefore, we get E equals to constant into V, and here that constant is taken as H. Therefore, equation becomes E equals to HV, where E is energy of radiation. Here N means integer, that is we take from 1 to 3 to infinity. H is Planck's constant, and N is or V is frequency of light. And the constant H, that is Planck constant, has value 6.63 into 10 raised to minus 34. joule second, or it may be written as 4.14 into 10 raised to minus 15 EVS. And here this photograph shows the how the electrons are emitted from the metal surface. Here we say that when light of suitable frequency is incident on that metallic surface, then electrons are emitted, and that effect is called as a photoelectric effect. Then what are the properties of photon? Here we know that photon means it is the units, or it is the packets, energy packets. And first property of photon is that it is a indivisible entity, and therefore the existence of photon is same as the existence of electron. Second property is that photons travels with the speed of light, and we know the speed of light is given by c equals to 3 into 10 raised to 8 meter per second. Third property is photons cannot be deflected by magnetic field. Fourth property is photons are electrically neutral. Fifth property is photon do not ionize. Sixth property is mass and momentum of photon. And to find the mass and momentum of photon, first we consider that according to Einstein's theory of relativity, the equation is E equal to mc square, where E is energy, m is mass, and c is velocity of light or speed of light. Then here we know that energy of photon is given by hv. Therefore here we put E equals to hv. Therefore equation becomes hv is equals to mc square. Then when we take that c square on left hand side, therefore equation becomes m equal to hv upon c square. But we know that v equals to c upon lambda, where lambda means wavelength. And when we put that value, we get m equals to h upon c lambda. And here in this equation, E means energy of photon, c means velocity of light, and h means Planck's constant. Then we solve MCQ. First equation is according to photoelectric effect, light energy is converted into. Option A is electrical energy, option B is mechanical energy, option C is frictional energy, and option D is kinetic energy. And we know that when light of suitable frequency is incident on metallic surface, then electrons are emitted, and due to that light energy is converted into electrical energy. Therefore correct option is A, electrical energy. Then question number 2 is energy of photon is given by. Option A is E equals to hv, option B is E equals to h upon v, option C is E upon h equals to v, and option D is none of these. And we know that if nu is the frequency of light and E is the energy, then the energy of photon is given by E equals to hv or h nu. Therefore correct option is E equals to hv. That's all about today's video. Thank you.